Example number 36 here. Integral 0 to pi by 2 log of mod of sine x. So here we had one similar question in exercise. Same way we do this question. So by by a property, you first replace x by pi by 2 minus x. So here therefore I equals to 0 to pi by 2. This is log of sine pi by 2 minus x. It's a cosine x. What we did, we have used this cosine pi by 2 minus x equals to sine x. Now once we use this property, always we add these two equations. So now adding 1 and 2. Just adding 1 and 2. What is left hand side? It will be 2i. What about right hand side? Log of pi by 2, it limits from 0 to pi by 2. Log of sine x plus log of cosine x. Here we use that property that addition becomes multiplication. So here integral 0 to pi by 2 log of sine x into cos x. Now if you remember, I want to set the formula of sine 2x. So into 2 by 2. And now again the property of the log function, the numerator will be log of sine 2x. And division becomes subtraction. So this is minus log 2. Fine. Now split into two integrals, 2i as it is here, 0 to pi by 2 log of sine 2x as it is, minus here log 2 being constant will keep outside, 0 to pi by 2 1 dx, because log 2 already taken outside. Now over here 2i equals to, I'll call this as I1, which we need to compute separately. Log 2 as it is here. What's integral of 1, which is x, and upper minus lower, so we'll get just pi by 2 minus 0. We call this as 1, big one. We'll find I1 and we'll place here in this equation. What is I1? That's this integral. So where I1 is this integral 0 to pi by 2 log of sine x sine 2x dx. Now what we'll do first, you recall as we did earlier, we'll put 2x equals to t here. So you'll get the 2 times dx equals to dt. So dx equals to half dt. That is one thing. We need to change the limits also. If x is 0, t is 0. If x is here pi by 2, put pi by 2. So t equals to pi. 2 will get cancelled. So therefore that I1 will be 0 to pi, new limits. dx is half dt, and here you have log of sine t dt. Okay. Now if you just recall, log of sine pi minus t, second quadrant, so we'll get the log of sine t. So according to one of the property, 1 by 2, the integral will be double and limit will be half. So here you have 0 to pi by 2 log of function will be same, log of sine t dt. Which property I've used? If you remember this one, 0 to 2a fx dx equals to twice 0 to half of this if f of here 2a minus x equals to fx. We had this property that I've used here. 2 will get cancelled, so integral 0 to pi by 2 log of sine t dt. Now what is this log of sine t? It would be, if you just go back to beginning, it's just represent I. So I1 equals to I. This is because of 1 and therefore by 1, have a look on 1, 2I equals to I minus log 2 into pi by 2. Take I on this side, so 2I minus I equals to minus log 2 into pi by 2. That's required integral. This is also an important example. We had in the beginning of this chapter such question. Take the highest power of x common. So I'll take x raised to 4 outside from this. So it will come as x. Here you have 1. If I take x raised to 4 outside, here you have x by x raised to 4. So it is just 1 by x cube. Whole raised to 1 by 4 upon x raised to 5. So this is 1 minus, this is x raised to minus 3 the whole raised to 1 by 4 upon x raised to 5, 1x will get cancelled. This is x raised to 4 dx. So now you know how to do this. Derivative of this is x raised to 4. So I'll put x raised to minus 3 equals to t. So minus 3 into x raised to minus 4 dx equals to dt. So dx here 1 upon x raised to 4 minus 3 I'll take on the other side. So this become dt now. So minus 1 upon 3 being constant outside. This is 1 minus t raised to 1 by 4 dt. And this can be now integrated very easily because this is just a linear function with the coefficient of x equals to minus 1. So 1 minus t raised to 1 by 4 plus 1 upon 1 by 4 plus 1 into coefficient of x, which is minus 1 plus c. So finally here this minus will be plus 1 by 3. 1 minus what was t, that is x raised to minus 3. This is nothing but the 5 by 4 upon 5 by 4 plus c. That's required integral. If you want, you can simplify further also. This your answer. 39. This is again a good question here. The first question is, can we use partial fraction method here? Because in the denominator you have linear and quadratic. The answer is no. Why? Because here numerator has more degree than the denominator, 4, and here maximum is 3. So we need to simplify this. Remember, how will simplify? We try to set this expression over there. So we know that x raised to 4 minus 1 can be factorized very easily. So here adding and subtracting 1. This is right now as it is. This is very important step, remember here. Now what we'll do is this upon this individual division here. X raised to 4 minus 1 upon here. Upon what we have, x minus 1 into x square plus 1 plus here 1 upon x minus 1 into x square plus 1. What about the first integral? It has factors here. X square minus 1 which is in turn x minus 1 into x plus 1, and the other factor is x square plus 1. So here you can see that the entire denominator will get cancelled. What are the factors of x raised to 4 minus 1? X square minus 1. This is x square minus 1. The other factor is x square plus 1. You know that this cannot be factorized. X square minus 1 has these two factors. So this will get cancelled, this will get cancelled. Here you are left with this. How will do this? Let me just copy right now this expression over here as it is. Have you noticed how to do this? So the first term is just integral of x plus 1. And here, let me call this as I1. This is I. How will do I1? How will solve I1? So that you know, partial fraction method. Linear, so one constant. Now you can use partial fraction method. Why? Because here you have just constant and this is cubic equation. This quadratic, so bx plus c upon x square plus 1, and now you know how to do this. So continue for partial fraction method, so you can do it. This can be integrated very easily here. So this is also a good question. If you remember points to remember, in such questions we put log x equals to t. If you are log an exponential, you should put log x equals to t. Now before I differentiate, I'll drop the log function. So x will be e raised to t. You know such things from continuity and differentiability. This is a property of log function. Drop the log function, so this will be e raised to t. It is assumed that your base is e, remember, you know it. Now I'll differentiate. So derivative is dx, here it is e raised to t dt. Fine, I'll place there. So I equals to, this is log of, I've taken log x as t. So this is log t, log x as t. So 1 by t square. And what is dx? That is e raised to t dt. I hope this is clear to you. I'll just remind you at this place. If you remember, if you have log x equals to y to the base a, if I drop the log function, then x equals to a raised to y. This is the definition of log function. In terms of exponential, this is in terms of log. Here nothing is given means base is e. So if I drop the log, this is e raised to t, and then just differentiation. Now what we do is here, you might have noticed e raised to t is there, so you must have function plus its derivative, that is f plus f dash form, because outside you have e raised to x here. Okay, so you need to set the derivative. I'll keep e raised to t as it is. What's the derivative of log t? 1 by t. So I'll add 1 by t. If I add 1 by t, I need to write minus 1 by t. Plus 1 upon t squared is already there, the whole dt. What I did, I've subtracted and added 1 by t. Why? To set f plus f dash formula. Now you see, this is f, this is f dash. Again this is f and this is f dash. What's the derivative of 1 by t? Minus 1 by t square, but here minus sign is there, so we have plus 1 by t square. So that result twice, e raised to t as it is. From here fx means log t, and from here you have minus 1 upon t plus c. We have used this result twice, remember here. Now put the value of t. What is e raised to t? You know it is x. What about this? Log of t. What is t? That's log x. Minus 1 upon t. What is t? That is again log x to the base e plus c. So this required integral here. We have used that result how many times? 2 times, remember. Here we have used this result e raised to x f plus f dash how many times? 2 times. E raised to x into fx plus c. One for this 2 and one for this 2, remember. Okay. So in this again modulus question, we get x for which this becomes 0. So x sine pi x equals to 0. It implies either x equals to 0 or sine pi x equals to 0. Now here you have from 0 to 1.5. 1.5 means less than pi by 2. So here you have pi x equals to, let me write n pi, zeros of sine function. Pi will get cancelled, so x equals to n. N means natural number, integer. So you may have 0, then 1, and 2 you cannot take because here maximum it is 1.5. So we have only 2 values here and 1 from here. So therefore either x is 0 or 1. These are the values for which this becomes 0. So we split here at 0 and 1 both the places. So minus 1 to 0, then you have 0 to 1, and then one more integral which is from where to where? 1 to 3 by 2. Now from minus 1 to 0, 0 to negative side. So this is fourth quadrant. There sign negative, x is negative, so both will be positive, so you can replace by itself. 0 to 1, so this is less than pi by 2, the first quadrant, so again both are positive. So here functions are same, so if you want to merge this one as a single integral, you can write directly minus 1 to 1 x sine pi x. Plus, now what about this? It is obvious that if here both are positive, then it has to be negative here. Remember, the inner function has to be negative. Or how do you explain this? From 1 to 1 by 2. So this is positive, but here you need pi x. So if you do pi x, this is limit on x, remember here. It's like this. Your x is from where to where? 1, 2, 3 by 2. You need pi x. So if I multiply with pi, you can see it will fall in which quadrant? That angle will fall in which quadrant? Pi to 3 pi by 2, third quadrant. Their sign is negative. A negative, A positive. So pura andar negative hua. So when you drop the modulus, it would have minus sign. Okay, so here minus integral from where to where? 1, 2, 3 by 2 x sine pi x dx. And now this is not difficult to integrate, remember. You can do it very easily. How you will integrate? Both by parts, remember. You need to do integration by parts here as well as integration by parts here also. By parts you need to do both. So do it and then you write upper minus lower. So that much you can do. Only this part is important, how to drop the modulus. So here first we use that property and we replace here this definite integral x by pi minus x. So therefore I equals to integral 0 to pi, numerator is pi minus x, a square, this is cos square, x is pi minus x, plus b square, sine square pi minus x. Pi minus x, second quadrant. sign positive, cos negative, but because of square it remains same, remember. So 0 to pi, I'll do here individual division. So pi upon a square cos square x plus b square sin square x minus here 0 to pi x upon a square cos square x plus b square sin square x. Now you can just see equation number 1. This is nothing but I. So you take this one on the left hand side. So left hand side will be 2i. Integral 0 to pi upon a square cos square plus b square sin square. Now here 2i equals to pi being constant, I'll keep it outside. 0 to pi is 1 upon a square cos square x plus b square sin square x. Now what we'll do is, if you just notice here, a square cos square pi minus x plus b square sin square pi minus x equals to, we'll get the a square cos square x plus b square sin square x. So here it's like f of pi minus x equals to f of x, remember. So we have by one of the property 2i equals to, here pi is already there, integral will be double and limit would be half. So you have here 0 to pi by 2. The function remains same, remember. So a square cos square x plus b square sin square x. Function will be same, remember. Which property I have used? You know, if you have 0 to 2a fx dx, then you have twice 0 to integral will be double, limit will be half, f of x dx. If this condition is true, f of 2a minus x equals to f of x. So here you have 2a, here you have pi. So if I replace function by pi minus x, you will get the same. So we could write this. So this 2 will get cancelled. So we get here next one, that is I equals to, here I equals to pi into integral 0 to pi by 2 1 upon a square cos square x plus b square sin square x dx. Now this is very standard type of the integral. What we do is we divide numerator and denominator by cos square. Dividing numerator and denominator by cos square. So here by cos square, here whole by cos square. Why we do this, you will realize in the next step. So what's the numerator? It is x square. A square as it is, cos square, that's just 1. B square and sin square by cos square, which is tan square. Now you must have noticed the derivative of tan is x square. So put tan x equals to t now. Putting tan x equals to t. So what is this? X square x dx equals to dt. And we need to change the limits also. If x is 0, put 0 here. So tan 0 is 0. So here 0. If x is pi by 2, put here pi by 2. So t equals to 10 pi by 2, which is infinity, undefined, 10 pi by 2 is undefined. So therefore pi into integral 0 to infinity, this dt here, this is a square, this is b square t square. Now, this is very well known formula, x square plus a square, 1 upon a, tan inverse x by a, x means bt here, bt by a upon the coefficient of t, which is b. Which formula I've used? Let me show you here. 1 upon x square plus a square, if you remember. So 1 upon a tan inverse x by a, remember, plus c. Here x means this expression, remember. And what's the coefficient of t there? Which is b. So I need to write upon b. This a square, here your by a, here this a. And what are the limits? 0 to infinity. So outside pi a b as it is. Here you put infinity, tan inverse infinity. So tan inverse infinity means reverse. You just look at here. So it's pi by 2. For what value of the theta, tan theta becomes infinity? That's pi by 2. Minus, you put the lower limit, which is 0. So finally, we are getting here pi square 2ab. Here I'll put infinity, I'll repeat. So tan inverse infinity. What's tan inverse infinity? It's pi by 2. For what value of the theta, tan theta becomes pi by 2? Tan theta becomes infinite. So you have here pi by 2. Just you will get from these only. Put 0 here. So tan inverse 0 is 0. So pi square ab is your answer.